In this lesson, we're going to look at statement, reasons, proofs. We've seen some of these when we've done them on homeworks and quizzes and that kind of thing, but this is the formal process. A proof is a formal geometry proof is a series of statements in logical order. All right, so you are making a statement about something in logical order, and then you are going to justify it by a reason. Remember all those conclusions and reasons we did? Well, we're actually going to create a proof that follows one step logically the other. All right, so let's talk for a minute about what's important in a proof. The first thing is the statement. You will be given a lot of givens. That is stuff that we know, all right? When you use your proof, you should start with one or more of your givens. So you're going to use one of your givens to draw a conclusion. Each statement should be a fact or be true that is relevant to the problem. So facts and true statements that are relative to the problem, you have to make sure that what you're talking about has to do with what the problem is. Now, the next part is the logical order. Every statement that you make should follow from the previous statement or from given statements that you have. It should be logical. It should be a direct conclusion from one or more previous statements, or go together with one or more of the previous statements to lead to a conclusion. All right, so you have to make sure that it follows one after the other. The statement before that has to do with the statement after that, and so on and so forth. And when you are finished with a proof, your final statement is whatever to be proved. So where it says prove this, that should be the final statement that you write. All right, now we've done a little bit of reasons. Reasons are the reasons why things are true, or why we can say the statement is true. It's a why. They're referred to by previous statements. Okay, so the acceptable reasons that we know. Given statements. Only if it says in the given that this is given can you write given. You can't just say because it looks like it is. It's given because it's given. All right, definitions can be used as a reason, but you have to write them out. Perpendicular lines make right angles. Straight angles 180 degrees. Any kind of definition that you have to write out. Other reasons that you could use are postulates. All right, we have named for a few of them, but most of them right out. Like you can use addition, subtraction, the reflexive postulate, any of those. You can just use the name. If we state any other ones, you have to write them out. Okay, and previously proven theorems, which you write out. We're going to be looking at some theorems you use. We do have, an example of a theorem is Pythagorean theorem. All right, well, we're going to be looking at some other theorems that we're going to be using. We're going to prove them so that we can use them as a theorem, but you do have to write them out. So, what you have to do when you're doing a proof is mark the givens in the diagram, see what you know. All right, very important. Your diagram is important so you see what you have. Work backwards. Figure out what you need to prove. So look at your given, look at your proof, say, okay, I have this, I need to do this, how am I going to do it? All right, so mark the givens, work backwards, have a plan. Figure out how you're going to do it, and then write the proof. All right, let's see if we can write this proof. The first step is to read your givens. Angle KJM is congruent to NJL. All right, KJM is right here, is congruent to NJL. Notice I'm marking my diagram so I can see what I have. All right, I want to prove that KJL is congruent to MJN. All right, so I'm going to color those in so I can see what I'm trying to prove. I'm trying to prove that KJL, this part right here, is congruent to MJN. I have to figure out how to go from what I have to what I want to end up with. All right, so we need to come up with a plan. What plan could we do? Well, let's take a look at where KJM is. Does KJM have anything to do with either of these angles? Well, if you take a look right here, isn't KJL part of that? And over here, NJL is part of this angle over here. All right, so this little piece is part of this angle over here that we are given. So here's the two given angles. Here's the two angles we want to prove. Probably, what are we going to have to do? Well, if you think about your postulates, what you're going to have to do probably is subtract. So our plan that we're going to do, you don't have to write a plan normally, but I'm going to write it here so you can see where we came from, is we are going to subtract the angles. And if we subtract the angles, we can get the angles we want. Now, we have to do this in a logical way, so you have to remember how the subtraction postulate works. All right, so let's begin. The first step is you write down your given statement that you're going to use. Well, we only have one given, so we're going to write that here. So I've written my given statement down, and since that is my statement, my reason that is true is because it was given that it was true. So I can just write given. All right, now we decided that we're going to subtract the angles. Now remember, when you subtract the angles, you have to have two congruent statements. Do I have two congruent statements here? No, I don't. But if I take a look at my diagram here, I want to be able to subtract from this angle, I want to subtract out LJM. And to get this angle over here, I also have to subtract LJM. So I'm going to have to get a congruent statement there so I can use the reflexive postulate. So what I'm going to do is I'm going to say LJM is congruent to LJM. And I'm using the reflexive postulate to do that. Now the reason I'm doing that is because I know I'm going to use subtraction. So in order to subtract, I have to have two things. So I'm actually subtracting the same thing from each side. All right, now you want to write the subtraction. Remember, it's this minus this is congruent to this minus this, or what you end up with. So let's see what we have. Angle KJM minus angle LJM, this one minus this one, is congruent to angle NJL minus angle LJM. Or what do you end up with when you're done? Well, you end up with angle KJL is congruent to angle MJN. All right, and what did we just use to do that? Well, we just used subtraction. Okay, now remember we said that our final statement should be what we were trying to prove? Well, look right here. Our final statement we were trying to prove was KJL is congruent to MJN. There it is, we've proved it. So that is an example of writing a proof. Okay, so what we're going to do is we're going to leave the last proof on the back for class tomorrow or Monday or whenever we have class next, so that we can figure out this process and then we'll work on the homework in class.